Unlike blockchain architecture, which focuses on the design of these layers, the technology stack refers to the implementational details, such as which software development kit is used to develop the applications, which language is used for programming the application logic, and which virtual machine options are available to execute it. Let us take the example of a decentralized exchange. This exchange can be used to trade and exchange assets 24 by 7 and 365 days a year. The application here corresponds to the front end, which could be a UI on a browser or a mobile app, as well as the smart contract code that executes the core logic on the blockchain network. A wallet account interacts with this application through a node client. The transaction orders placed through the UI are signed by the wallet account and submitted to the node client and are sent for execution on the blockchain network. The transaction is typically executed on a virtual machine like Ethereum Virtual Machine, EVM. The blockchain network nodes come to a consensus on that particular transaction. All of this is achieved through nodes and the blockchain network's infrastructure. Finally, there is the blockchain tooling that allows you to query and interact with the network. For instance, if you'd like to check if the transaction is executed, you could use tools like block scanners. Now let's talk about blockchain nodes. The technology choices made regarding the node have a direct impact on the whole blockchain network. What programming language is used to implement the core logic, which virtual machine executes this logic, and what is its design, how fast is the consensus, and whether it is deterministic or probabilistic. How many nodes can the blockchain node connect to? How are the nodes discovered on the network? What would be the hardware and network requirements for running these nodes, etc. Now, given this context, let's examine the Ethereum network's technology stack. When you transact through an application that typically uses the standard Web3 JavaScript libraries, it is broadcast across the network nodes and executed within the Ethereum virtual machine, interacting with the respective smart contracts involved. This transaction is first executed within the Ethereum node selected to author the specific block in which it is included. The block with the transaction you submitted is then executed and validated by the rest of the Ethereum nodes, which run beacon, execution, and validator clients. After reaching consensus on the block, the blockchain transaction is finalized. Now, let's take a look at the technology stack of networks like Bitcoin and early version of Ethereum. These networks were never designed to communicate with other blockchains. Their prime focus was on decentralization and providing security, but scalability remained an issue. And then, unlike Bitcoin, Ethereum offered flexibility in terms of generic computing, but with its tech stack, offered little scope for customization of diverse blockchain use cases. The attempts to have on chain governance had some setbacks, and the upgrades to the network had the potential to split the network into what we call forks. Hence, the focus has been on enabling interoperability between blockchains, improving scalability and performance, improving the security of the networks without burning a lot of energy, making the technology modular and customizable, moving governance of the network on chain, and finally, making the upgrades to the networks seamless, like updating an app on your phone.